Hello, this is a revision video on the electrolysis of aqueous solutions. It's focused on GCSE and I'm going to talk about the AQA syllabus. Here we have a typical electrolysis setup with these two graphite electrodes that allow the conduction of electricity submerged into, this case, an ionic aqueous solution. In other cases you could have a molten liquid. Both allow the movement of ions as opposed to the ionic solid, which does not conduct electricity because those ions are fixed in place. They can't move around and carry charge. They're held together by their strong electrostatic forces of attraction. So let's start with the fundamentals. This negatively charged electrode we refer to as the cathode. The positively charged electrode we refer to as the anode. This table over here I'm going to use to convey what I believe to be the very key points of this topic in terms of answering GCSE questions. Therefore we can fill it out. The cathode is negative and the anode is positive. Now, there are different ions in solution. Some of them are positive and some of them are negative. Positive ions we refer to as cations, and they will be attracted to the negatively charged cathode. These anions will be attracted to the anode. A typical ionic substance that we all know is sodium chloride. This is ionic because it is comprised of the Na plus cation and the Cl minus chloride anion. These two ions are held together by their strong electrostatic forces of attraction, and sodium has donated its outer shell electron. It's now got a full outer shell, it's stable as an ion in its noble gas configuration, and Cl minus has gained that extra electron, giving it a full outer shell and also attaining noble gas configuration. By that I mean they have a full outer shell and they're stable just like the noble gases. Now, this is the cation, obviously here, and this is the anion. And if this was a molten liquid, we would say sodium is discharged at the cathode and chlorine as a gas is discharged at the anode. However, in an aqueous solution there is another compound present, which is water. And when exposed to an electrical current, this will separate into H plus and OH minus. So, when considering what is formed at the cathode, there's clearly a competition between the H plus and the Na plus. However, there's a very simple rule to help you through this. That is, copper, silver, or gold are formed at the cathode. In the absence of any of those three metals, we form hydrogen. Likewise, there's a problem at the anode. We have this Cl minus, and we also have OH minus. Again, thankfully, there's a rule that you need to learn, which is that at the anode, if a halogen is present, that is formed. And by a halogen I mean something that's in group 7. If not, OH minus wins the race, and oxygen and water is formed. And the equation for that I'm going to leave at the bottom here. It's a tricky one. I suggest you learn it. Is 4OH minus forming 4 electrons, 2H2O and O2. So here we can see the rules for what is formed. What I'm now going to look at is how we can apply these rules and get half equations. If you do foundation tier, this won't be a problem for you. If you do higher tier, you need to carry on watching, unfortunately. So, let's take a look at what has been formed in our sodium chloride example. We said that sodium will remain in solution, along with OH. A question they could ask you is, as the electrolysis proceeds, what happens to the solution? As we are taking out H plus and Cl minus out of solution at either electrode, and we know this because of our rules here, hydrogen being formed because we've got no copper, silver or gold, and the halogen being formed, but that group 7 element is present. So left in solution will be NaOH. They could ask you some properties of this. Obviously, sodium hydroxide is a very common alkali. But let's take a look at the half equations. So, for the formation of H+, we know we start in solution as H+, when subjecting that electrical current across the aqueous solution. We are going to form hydrogen gas. It's important to note that these H+ ions are an aqueous solution. We show them as AQ. The gas, hydrogen, is a gas at room temperature and pressure. We show that as G with the state symbols as it's being discharged. We now need to balance our atoms. We have 2 hydrogen atoms here. We've got a single proton here, so we need a 2. And we also need to balance our electrons. I like to think of this as balancing the charges across the half equation. Here we have a neutral atom, here we have a positive atom. Obviously electrons are negative, so we need to add them on this side to balance the equation in terms of charge. We now have 2 positive and 2 negative. Overall neutrality on this side, and obviously this side here is neutral as well. Let's consider what happens at the anode. We've got a halogen present, Cl minus. Again, we show that as AQ on the state symbols because that's what's in our beaker. That's what's undergoing electrolysis. We form Cl2 gas. Again, I need to balance the atoms with a 2. We then need to take a look at balancing the charges, and this time the 2 electrons belong over here, this side being negative and that side being negative. Remember, we don't really want to show electrons being taken away. This is shown in some other YouTube videos, not to big up my own channel, but the exam board will expect you to show the addition of electrons rather than the subtraction from the other side. We now need to look at which of these processes is oxidation and which of these is reduction. Now, we can look at this in 2 ways. The common mnemonic is oil rig, standing for oxidation is loss, reduction is gain. This is referring to electrons. Now, some of you may be able to look at this and see that the proton is gaining some electrons and is therefore undergoing reduction. Chlorine is losing 2 electrons and following our oil rig is undergoing oxidation. Now, this might be tricky to understand and you might be concerned when the exam asks you for either reduction or oxidation, which do you choose? However, the words are here to help you out. Oxidation has an A in the middle of it. I like to think of this as standing for anode, because oxidation always takes place at the anode. Reduction has a C in the middle of it. I like to think of this as standing for cathode, because reduction always takes place at the cathode. Therefore, in an exam, if you're stuck, so long as you know what will be formed at the cathode and the anode, you can use this cheat method of saying what is oxidized and what is reduced. I hope you found this helpful, and I hope that you understand that electrolysis is still a separation technique in this instance, and we are looking to separate positive and negative ions. All you need to do, in contrast with a molten liquid, is learn these rules for what is formed at either electrode. I'll do another video shortly looking at more of these half equations. Thank you very much.